This is Ty Newell, and in this video, we provide an introduction to the Is My Space Safe series. And the Is My Space Safe is meant to be a group of examples for different types of indoor spaces to help you understand the differences and similarities among spaces and how to move through the COVID Safe Space calculator in a manner that helps you find um, a group of settings that makes that space safe. So this is the front sheet of the calculator, and as you follow through other videos, you'll see how to use the different features of the calculator. And as we look at places such as a house of worship, this is very, very different from a house, from a restaurant, from a classroom. In a typical house of worship that may have one service per week, there's a peak, in this case, carbon dioxide on every Sunday, that is soaring to a level where your likelihood of getting infected, if there's an infectious person, is quite high. And the ability of the disease to spread and transmit is quite high. So, how do we approach a space like this to make it safer? How do we make a gym, your workout center, your home, a restaurant, or a school safer? And so we want to follow along through those characteristics. And as we make a space safer, typically through more fresh air, increased fresh air ventilation, improved filtration, perhaps reduced exposure time or limited number of people, and then personal behavior like wearing face masks, that we get it to a level where the disease no longer grows, it dies out, and our probability of getting infected has been lowered. And those are our two objectives with creating COVID safe spaces, a low probability of getting the disease, and then a transmission limit where an infectious person is no longer able to make more than one person infectious, what's called the herd protection limit. And building operation and personal behavior both combined in order to create a safe space. As discussed in the overall introduction, this COVID Safe Space IAQ calculator is meant to be a communication platform among different space holders. And in any and every indoor space, those stakeholders, perhaps you're a business owner, but then you're a parent of a child in a school, and then you need to shop for groceries. All of these spaces must be COVID safe spaces. They must be spaces in which the multiplication of this infection has been reduced to a level where it's no longer sustained and it dies out in order to protect our communities. And so it's important, no matter what role you may play as a stakeholder in each of these different venues, that you participate and you learn and understand and contribute in whatever manner you can to reducing the transmission of this disease. Let's just look at the way any number of these example videos will take. But for example, one slide out of the Is My School Safe video, where we look at a classroom that has perhaps 21 people, 20 students and a teacher, and one person in that classroom is infectious and other people are susceptible. And as we work from what would be the typical way that classroom would operate, in the upper left-hand corner of that chart with standard ventilation, standard MERV 8 filters, no face mask usage, that we would see that we have about a 50-50 chance for the time spent in the classroom, maybe 7 hours spent together, of susceptible people getting sick, about like a coin toss. If you don't get sick today, you're going to get sick tomorrow, okay? Because that person's infectious for more than one day. And the chance that that infectious person is going to spread it to two others, the infection multiplier, we see that in this situation, in the as-is condition, most likely 6 other people are going to get infected with COVID with one person attending that class. Now, as we increase fresh air ventilation, we go from 1,200 parts per million down to 800 parts per million of carbon dioxide, which is equivalent to doubling the amount of fresh air flow, going from about 20 cubic feet per minute per person to 40. We reduce the probability, the chance that you'll get sick by an infectious person almost in half. And likewise, we start reducing the number of people that infectious person is likely to infect. And before vaccination has propagated through much of the country, if we now add air recirculated through a good, efficient filter, a MERV 13 filter, rather than a standard MERV 8 building filter, we're now able to capture as much as 90% of the virus that's in the air. And that further drops the chance almost in half of you getting sick if an infectious person's in the room, and further dropping the number of people that infectious person is likely to make sick. And then let's say people, about half, are effectively wearing masks, or maybe everybody is for at least half the time. But let's say those masks are typical of ill-fitting cloth masks that we see today, or a bandana or some other uh, inefficient, leaky type of face mask that only captures maybe 20% of the virus. It's still effective, but not as much as having a larger fraction of people for a large fraction of the time wearing efficient, effective, leak-free masks. And the difference as we move from no mask wearing to efficient mask wearing by all is that we reach a level where now infection probabilities drop from nearly half to only 2%. And the multiplication of the disease has dropped from 8 or 9 people per infectious person in this classroom to less than one. The herd protection, the herd immunity limit, where the disease dies out. And one other thing we're going to see among these examples, similar to this classroom, is that as we get vaccinated, as we hit 50% vaccine limit and 75%, somewhere in that range is where we expect herd immunity to be reached. And we can see that as we move down this chart and then move to the right with different levels. So at 50%, 10 people out of the 20 susceptibles now have protection. And at 75%, now 15 have protection and only 5 are susceptible. We see that we reach herd immunity sooner, or at least with less effective mask wearing. But here's the important thing. Even though this shows that in the community, that if I double fresh air ventilation and I improve filtration from a standard MERV 8 to a MERV 13 filter, with 75% of the populace vaccinated, I now have reduced the infection multiplier below 1. The disease can't spread in an accelerated manner. And I still have a reasonably low infection probability. But as you go from everyone susceptible to almost everyone immune, notice that the infection probability for susceptible people has not changed. So for those of you who refuse to get vaccinated for whatever reason, and for those of our populace unable to for other reasons, for medical reasons, cannot get vaccinated, that the chances, the risk of you getting infected if an infectious person enters that room stays the same. So as you move through the COVID safe space calculator and you go through these examples, that's what we're watching for, to get the infection multiplier below 1, but also understanding that while a vaccine helps us to reduce the infection multiplier below 1 so the disease dies out, As long as there's a traceable amount of the virus in a community, we need to protect those by wearing face masks and taking other actions until finally no trace of the disease exists. You're at the same risk of infection whether there's herd immunity or not. Oh, let's end on this as you go through these examples that once you have set up your situation and you put in the number of people, you explore the number of people infected versus the number of people susceptible or vaccinated or immune, and then you make changes to the building's operation, its fresh air ventilation level that we determine by carbon dioxide levels and by the filtration level. And then you look at the importance of wearing face masks that are low leakage and high efficiency. You can see the steps needed to make it so you have a COVID safe space. But beyond that, you need to explore the sensitivity of your space. You need to look at reducing the vaccine efficacy because perhaps a variant comes in that makes the vaccine no longer as effective to the new strain. You need to look at the shedding of the virus and look at if the virus shedding rate, the number of quanta per hour per person, were to increase, whether or not you create a space that is resilient, that still keeps the infection multiplier below 1. And you need to look at other things that may help give you redundant protection. So even though your building may have a central air circulation system that's been outfitted with MERV 13, MERV 16 HEPA filters, that if that failed, or if someone mistakenly put in the wrong filter, a MERV 8, so you've lost that protection, that a space room filter could provide the backup and the redundancy and be operating in tandem and keep you protected while the other system is being repaired. So you need to explore, you need to use this tool in a manner that lets you figure out how to have a resilient COVID safe space. And any questions, contact me, Ty Newell. Contact me at tynewell, one word, at illinois.edu.